All ready to start. Okay, so today Bruce Calder, VP Consulting Services here at Claigan, I'm going to do a lunch and learn on the UN Stockholm Convention on Persistent Organic Pollutants. It's going to be a little bit in depth with the time allotted. I'm not going to get into all the bureaucracy. There is a lot of bureaucracy. There's a mountain of bureaucracy, but it's going to be fun-ish. Trademark. First off, something that has nothing to do with Sweden or chemicals. I enjoyed this. This made me laugh. Thinking back on it, that actually makes sense. Not the story, but their commentary. So, my memories of Stockholm, we're in Stockholm, being dressed up like a prisoner, being put into a gang, having to compete against other gangs, sleeping in a cell overnight. By the way, which is really, you get a window in the cell because in Sweden, the sun comes up at 2 a.m. And that was in London, which is their version of Alcatraz. That's my memory of Stockholm, and the fact you can also take a boat to the pubs downtown. But I was unfortunately in a cell, so that wasn't happening. This is like escape rooms before they had rules. It was something. Anywho, Stockholm Convention on Persistent Organic Pollutants. There's a link there. You can go to the convention page. It's got a lot of stuff. They only that a large bureaucracy could have. There are a lot of good details. It was adopted a long time ago. It was adopted before some people here were born. Quite a few of them, actually. It's adopted at the Conference of Plenipotentiaries on May 22nd, 2001 in Stockholm. So, like the Montreal Protocol and all those conventions, they get the name after the place that paid to host it. There is some value in paying to host these kind of things. First of all, plenipotentiaries, that's the American English spelling. There's a sh, plenipotentiary in English, American English, but British English, of course, has to be different, or the American English has to be different, depending on your point of view. Plenipotentiary in British English. I'm not sure which Canadians use. Like, should we use the British one? Like lieutenant instead of lieutenant. So I'm going with the pronunciation representatives. I think that's a better one. Um, why do we care about the pronunciation? Because it was cool, maybe. But what do we care about the Stockholm Convention? Okay, this UN Stockholm Convention is the basis of the restricted substances in every national pop legislation. They don't 100% agree. I'll explain why. They could have more or less, but it's generally the driving force for when we look at something, say, in EU pop or the Canadian prohibition of certain toxic substances. And what we used to call Australia Pop, whose real name is Australia ICHEMS, Australia Industrial Chemicals Environmental Management Standard, ICHEMS, which is one doozy of a long acronym, but that's the Australia version of POP. And Singapore. Now, Singapore one we don't bother with here as much because it's covered by the other ones, and you'll see later has some pretty exceptional exemptions for the actual situations where things are used. It's one of those jurisdictions that often bans it, except for in some places where it's actually used. So there are quite a few countries in this. What's restricted in POP are an Annex A. There's a link there to Annex A if you get very bored and you go to the slides, and includes a lot of these well-known chemicals like buzzaldrin and chlordane. And wait a minute, that's an astronaut. Whatever. A lot of these are pesticides, so you won't recognize them. Some you will, like Deca BDE, and all of these ones too. So there's a lot that's banned there. If you do like the old REACH restrictions or the original POP, you'll see things like Mirex and stuff that's very low risk in physical products. A lot of the historical ones are pesticides. People have been involved, like the Canadian representative from the POP Stockholm's conventions and to start, were mostly pesticide people. So it's often now the people looking at MCCPs or the flame retardants are actually pesticide trained people because that's where a lot of the original ones came from, like Murex. So the ones we care about is a subset. Deca-BDE, that's the ROHS banned substance. Dechlorine Plus, which gets more and more interest here, and we're doing more and more work on Dechlorine Plus. HBCDD, it's could be in the materials and rubbers, but it's so rare. It's very unlikely. It's generally a low risk substance. Long chain perfluorocarboxylic acids, LFPCAs or LFPACs, depending on how you want to do it. The PFOA family and longer. It's the PFOA family and longer, which we do a lot of work. We see it here as, we do testing for P26. It's the longer versions of that. So you're looking at fluoropolymers. They're not these acids. These are chemicals that could be unintentionally in them. Medium chain chlorinated paraffins. This is the brand new one. This is going to drive some change, especially with our direct mass spec. We're going to be doing more testing with this. It's mostly a substance that makes phthalates or ortho or tera, ortho the restricted ones, tera the not restricted ones, work better. Primarily with orthophthalates, though. They make them work better. They make them adhere or be more compatible with PVC, especially the orthophthalates. The orthophthalates are the main users of chlorinated paraffins. And PFOA, which is kind of redundant, it kind of came in by itself. PFOA came in by itself originally. Then they added the longer versions of PFOA. O is octa, 8, and then everything longer, 9, 10, all the way up to 21 carbons length is the other one, the long chain perfluorocarboxylic acids, way above. It's the PFOA family. That's the best way to describe it. It's like the alcohols of the fluoropolymer family. PFHXS, which we see basically extremely rarely, it doesn't really exist. There is a version of it, a salt, a degradation of a salt we see in Viton very rarely called 6,2 fluorotelmer sulfonate, S62FTS. It's related to this family. Short chain chlorinated paraffins, which again is the historical and been restricted for much longer. MCCPs are just now, and we're seeing the European restriction just coming in soon. SCCPs have been banned in Canada and Europe for a long time. They are also a substance that makes the orthophthalates, the DHPs, the DINPs, the things that historically made PVC bend more compatible with PVC. They actually make them slightly safer in PVC, which those other chemicals cause attention deficit. It's actually not the worst idea to have these chemicals to make them leach out less and be safer. But because they're persistent organic pollutant, which I'll talk about the definition, they're being restricted because they build up in the environment. And UV328, which is a UV stabilizer that stops your LCD screen in front of you right now from discoloring in the sun. And I'll explain that one. So those are the main ones we're interested here. And if you're involved in physical products, one of the nice things about the Claigan Lunch and Learns is we do distribute this on YouTube to the wider audience. So you can get into much bigger, more technical understanding. These are the ones in physical products, especially electronics, you're most interested in. POP requirements. So to get added, to get restricted, you have to go into Annex A. So that added, you have to be persistent, not just the government official asking for it, which is also true. The chemical has to be persistent. And probably not surprising how often I've misspelled persistent. I always use T-A-N-T instead of T-E-N-T. Thank goodness Google knows I'm incompetent and fixes it. Bioaccumulant, it has to build up in the environment, has that potential for long-range environmental transport. It means they only care if it can get around. If it can't get around, they don't care. They care if it can move around. And it's toxic eventually. When it bioaccumulates, a lot of these are not toxic whatsoever initially. They have to bioaccumulate up until a concentration where they actually become toxic. Most of these are actually relatively benign in their normal form. They have to build up to actually become toxic. So what's persistent? Persistent is a person trying to get me to complete my tickets in base camp. For the POP or Stockholm Convention is the evidence that the half-life of the chemical in water is greater than 2 months. So half-life is the length of time it takes half of the chemical to disappear. Probably one of the most important things about half-life they don't know in your average everyday is the half-life of like Tylenol in your system or Advil, where how long before half of it dissipates. So Tylenol or Advil is only about 2 hours. And that means after about 2 hours, you've lost half the effectiveness. And after 4 hours, you're down to a quarter. And that's probably why by the time you're really jonesing for a painkiller, about 6 to 8 hours in, there's a reason for it. Its half-life is actually relatively short. Half-life is how they measure how much something stays in a system. For your medications, even simple over-the-counter ones, half-life defines a lot of how you're going to respond to it. How long does it take before it actually dissipates? So for them, for persistent, the measurement is what's the half-life? Is the half-life in water greater than 2 months? If you put, 100 kilograms of it in the water, 2 months from now will be over 50 kilograms less. Or it has a different version for soil. Soil, they don't expect it to degrade as fast, so it's 6 months. And sediment, it's also 6 months, which I think sediment and soil are pretty similar, but I believe people who are really into their dirt might know the difference. And evidence that or close enough. They have in every single one of these categories, they have like Yeah, close enough. Evidence the chemical is otherwise sufficiently persistent to justify its consideration. And that's usually the most argumentative one when countries use that one, as opposed to one of the straight metrics. So that's persistent. Bioaccumulation is evidence the bioconcentration factor or bioaccumulation in aquatic species for the chemical is greater than 5,000. So what it means is it accumulates. You get a dose, and then you get rid of a certain dose, usually by excreting it. You can imagine the ways an animal excretes things, or don't because you're eating. So what it has to do is you take the initial dose, can it build up in their body to over 5,000? Basically means the amount you're taking in comes in so much higher than the amount you excrete or get rid of. Does it bioaccumulate in fish to a concentration 5,000 times a dose? Or it's equivalent concern that it has high bioaccumulation, but creates a lot of toxicity. So it doesn't get to 5,000, but it becomes toxic before that point. So these substances are generally not very toxic originally, but as they bioaccumulate, they become more toxic. This one says the 5,000 limit is not a big deal if it's actually becoming dangerous long before it hits 5,000 times. 5,000 times is like 5,000 times of the concentration in the fish than the water. So imagine the water concentration has 1 microgram per milliliter. If the fish gets 5,000 times that, 5 kilograms per microliter in their body, that meets the first category. The other one doesn't care if it meets 5,000. If when it builds up, it starts to become toxic. Or there's other data. This is again, they all have this other category where it says other data is pretty darn close. And this is always the most argumentative one. But the first two are pretty good. You get over 5,000 magnification in the fish, that meets it, or it's magnified and it's become toxic at this point in time. There's not a lot left over. It's pretty creative at that point in time. It has to have potential for long-range environmental transport. It has to be able to get places. If it doesn't get anywhere, they don't care as much. Because if you put it in a river, so that's one of the reasons, one of the reasons things something lead is often solid lead is not a persistent organic pollutant because it just sinks the bottom. However, dissolved lead can get around. So this has to do, can it get around? If it's absolutely inert, it's not getting anywhere. So it has to have potential that it'll move around. It could be a liquid, could be a gas, could be, some kind of diffusion. It has to be able to get around. Or salt. The measured level of the chemical and locations distant from the source of its release that are potential of concern. So you release it here, you can still get concerning levels, either toxicity or bioaccumulation, far away from that source. Or similar. There isn't as good math in this, and or similar gets a lot hand wavy. Basically, they want to be able to show, especially things like PFOA, which is surfactant, which doesn't usually stay very high concentration because it spreads fast. Because surfactant, it has low friction. It basically spreads incredibly quickly. So the other or similar category has a lot to do with PFOA. It really spreads, but it doesn't necessarily bioaccumulate because it spreads so fast. And so there are extra rules around that. So it has to get places. If it doesn't get anywhere, they don't care. If it's a stone drops the bottom, doesn't go anywhere, they don't care. If it's stone dissolves and that chemical gets released and moves everywhere, that's what they care about. Adverse effects. And you need to prove it does something harmful. Now, if it bioaccumulates enough, everything does some harm. Evidence of adverse effects to human health or the environment, flora and fauna, or fishies are usually the metric, that justifies consideration of the chemical. So it has to do something bad when it accumulates. If it doesn't, they're like, meh. Usually when you get to 5,000 times magnification, bioaccumulation, something bad's going to happen soon. Or you have, again, this hand wavy toxicity or ecotoxicity. Toxicity is like animals, and ecotoxicity could be like plants, data that indicate the potential for damage to human health or the environment. So you got to be able to show it does some sort of damage. If it doesn't do damage, they don't care. So it has to be persistent, has to stick around, has to bioaccumulate, has to go up in concentration, has to move around, and it has to do a bad thing when it's done those things. If it doesn't do a bad thing, they don't care. So it has to meet all those four criteria. So it's different than, say, DHP, which right off the bat, kills brain cells, especially early in life, creates reproductive toxicity, attention deficit. Those are reproductive toxins, have effects right away. These have more to do with bioaccumulation and then eventually getting around and eventually causing damage. So overall, how the process works, the Stockholm Convention, the process is A country or national association, almost always a country, nominates a substance. It's actually a very simple thing they have to submit with a lot of science paper references. The substance is reviewed by a POPRC. I've interacted with them. We've submitted stuff to POPRCs, the Precision Organic Pollutant Review Committee. And then it's voted on by the representative of member states. Notice I'm saying representatives, not plenipotentiaries, representatives of member states, which is mostly what they're called these days, or delegates, just another word that's a lot easier to say. Um, it's voted on by representatives of member countries. So eventually, all the science happens and their vote happens. And then the member countries have to implement restrictions into their own legislation because, keynote, companies and products do not have to be compliant with the UN Stockholm Convention. And you're like, well, why are we even talking about this? Like, I've got a meal, I got lunch. That's pretty awesome. But if this has nothing to do with this, what do I care? No. So you don't have to be compliant. Your company doesn't have to be compliant. The product, the UN Stockholm Convention directly. The UN Stockholm Convention has no direct power over companies or products. Companies have to be compliant with the applicable national implementations of the UN Stockholm Convention. And they keep track of these on the website on the UN Stockholm. So, which might not occur in all countries or for all substances. And they might only be in chemicals, not articles. Articles are physical products, where we generally here at Claigan, we're more concerned. We do a lot more work in physical products where we have core expertise. So you actually have to be compliant with whatever the country puts into place, which may or may not. They're supposed to be the same, but they often end up being the same-ish. And as they go through the sausage maker of their own national legislation, they don't necessarily coming out as a sausage. Now, there are a lot of members. There are 185 countries. So theoretically, if this is to be done properly, we should be doing compliance for 185 countries, plus the EU makes 186. And this is a huge list. Dominican Republic is a signatory. Like theoretically, Declorin Plus should be restricted. It isn't yet. In the Democratic Republic of Congo. But I don't think people be as concerned with countries that don't necessarily have a full regulatory framework. It could be Antigua and Barbuda, could be Angola. They're all members. 180, it says 152 signatures. There's really 185 countries. Complicated description. But everybody but the United States. So everybody signed in except the United States. China signed in. US is not. So the US is not signed into any. Now they have a lot of stuff on their website about this, but they haven't signed up to do any of these commitments. So it's everybody based in the world except the United States. So I'm giving you an example of a substance we work on relatively commonly, Declorin Plus. It's a gas phase flame retardant. So the way it basically works is the rules are for plastics flame retardancy. This flame retardant doesn't make it burn less. You're like, then what's the point? What it actually does is the way the test works for flame retardancy in electronics is you put a candle under it, which is nowadays a Bunsen burner, and it's allowed to burn. Can't drip hot plastic, but it's allowed to burn while the Bunsen burner is running under it. Once you take the Bunsen burner away, there's a stopwatch going. It has to self-extinguish right away. And the way it does that is it actually has a sink for the energy. So when the plastic burns, hydrogens pop off. They're very excited. They're hydrogen radicals, a very energized particle. If they react with itself, they become H2, which is actually a fairly stable compound. All the leftover energy gets kicked back in the plastic and burning continues. What does the chlorine or bromine is the hydrogen reacts with a much larger chlorine or much, much larger bromine. And that bond, the bigger molecule, can absorb more of the excited hydrogen's energy. Then the HCl, hydrochloric acid, or HBr, bromic acid, reacts with antimony trioxide, which is why whenever we're looking for Declorin Plus or DBDP or DecaBD, we're always looking for antimony trioxide to go with the bromine or chlorine because it needs the bigger antimony to absorb even more energy than the chlorine or bromine did themselves. So what it is when it's burning, it doesn't make it less flammable. It uses the bond energy to chlorine or bromine and then into antimony to suck up the excess energy from combustion and cause the plastic to self-extinguish. So very common, very important for thin plastics. Declorin Plus is actually a brand name, a trade name. Everybody uses the trade name like people use Kleenex because the real name is a doozy. If you ever had to do organic chemistry, poor souls, which I have had more than once, you have to end up naming the location of every single one of those chlorines and relative to the double bond and where's the double bond. And it ends up with this incredibly long, complicated description. And that's why everybody calls it Declorin Plus. because you can't, the other one doesn't roll off the tongue, and good luck remembering all those numbers, especially with, different aluminums in our food sources. Anyway, it's an infrequent flame retardant. We do see it more than we thought. We see it primarily in heat shrink and transformer wrap, whether it's the yellow wrap you see in a transformer, or often there's a white wrap underneath it. That's usually the most common place for it. It's very similar to the ROHS band Deca BDE or the newer regulated DBDP, which is very similar. The brominated ones generally work better because the bromine's a larger molecule than the chlorinated ones, but both exist. So that's the use of dechlorine plus. So for us, where we see it is using heat shrink and transformer run. Now, where it's actually regulated originally, it's the EU REACH SVHC, which substance of very high concern, which doesn't ban it, it doesn't restrict it. You just had to communicate it if it was in a component above 0.1% concentration. And it's been an SVHC since January 2018. By the way, again, if you see that kind of hyperlink under it, that's a link to the legislation or the guidance, or in this case, the actual REACH SVHC list. It's a very newly regulated EU persistent organic pollutant regulation. It's restricted. So it's restricted under EU POP. There's a link there. It's pretty new. It's banned as of October of this year at 1,000 parts per million. It is supposed to be banned in April 15th, 2028 at 1 ppm. This one's unlikely to stay. There's a technical science, stupid, because it effectively bans recycled plastic. Because this has been in the electronics for so long, if you recycle any electronics, which under the WE directive, which drives a lot of this, um, and a lot of the ROHS stuff, you're supposed to recycle your plastics. It ends up there, and the Waste Management Association could see it in the just sub 10 ppm range. So it's going to be there in low concentrations just because of recycled plastic, other reasons. 1 ppm basically bans recycled plastic. And Deca BDE, which is the ROHS banned one, has been banned for a very long time, almost 2 decades. Its new limit in recycled material is 10 ppm. So it doesn't make sense for the Chlorine Plus, which has the same application and has been used in high volume much more recently, to have a much lower number. It will basically ban recycled plastic. So eventually I expect the associations to push back on this, say like, and then the government say, no, we want to make 1 ppm, and then point at the Deca limit, like, come on, they're the same. And you just approve that. And they're like, okay, but that's going to take some advocacy. So we've set it up internally. We have the test capabilities. We screen and then do the follow-up testing down to 1 ppm, but we expect this limit to change to 10. Dechlorine Plus ICHEMS. So this is the Industrial Chemicals Environmental Management Standards, ICHEMS. We called it Australia Pop. So a lot of times if we're quoting or talking to customers, we call it Australia Pop because it basically is. It's just his real name is the Industrial Chemicals Environmental Management Standard. It's restricted Dechlorine Plus in Schedule 6. So there's a link there. And it's prohibited at July 2026. In absence, they don't have a limit yet. They're going to choose limit 2027 of what unintentionally contaminant levels are, which is a pass. So if they haven't, it becomes the SDS reporting limit of 1,000 ppm. It's a de facto limit. Exempted from the ban, mostly until July 2031, are aerospace, defense, and repair parts. This is also where a lot of comments on is in Europe, aerospace and defense are also exempted. Like if you're going to exempt those, you're going to have so much dechlorine plus anyways. The 1 ppm versus 10 ppm really doesn't matter in terms of bioaccumulation. Again, we're not talking about you're poisoning an individual. It's not DHP. This is bioaccumulation. So if you're allowing this, then the 1 versus 10 ppm doesn't make a difference from bioaccumulation point of view. So lots of ammunition then. However, the neat thing about Australia is they have a brand new variation, not brand new. It's been there the whole time, but most people haven't realized it's there. Is if you have an exemption like your aerospace for dechlorine plus, you have a REACH SVHC-like communication in Australia. You have to communicate it to your supply chain, similar to EU REACH SVHC. Now, most standard products, whose risk of dechlorine plus is in the power supply, as of July of next year in Australia, it's banned. You can't have it, so this reporting thing doesn't matter to you. But if you're exempted, like spare parts or aerospace or defense, you have a REACH SVHC declaration requirement. You also have to give the same declaration to national authorities if requested. They often put the burden on the customs broker to make sure you have this compliance, like they do with asbestos. So instead of them asking for it, say, well, if you bring it in and we ask, they don't have it, the customs broker brought it in, it's your fault. And so you need to know substance, the concentration. They can ask annual volume, but that's optional and not likely for articles manufacturers. And the justification for use. If you're exempted, the justification is actually in the exemption in Schedule 6. So this is actually a very small group of companies. For Chlorine Plus, they would use it. There are exemptions to Stockholm Convention, especially around aerospace and defense. Often the national exemptions follow the Stockholm ones, but generally after the Stockholm Convention has restricted something, that's when industry figures out when they actually use it, because industry isn't directly represented in Stockholm Convention. They're associations and countries, companies are not. It's like for ourselves, we have to be represented through the Canadian Apparel Federation, who's wonderful people, to give them technical feedback. And so it's the communication requirement starts July 1st, 2026. However, the vast majority of electronics, you're already banned at that point anyways, and this communication requirement is kind of irrelevant. Singapore, they actually, under the control of hazardous substances, in the second schedule, they've restricted Dechlorian Plus. Now, do they know how they've restricted Dechlorian Plus? We've had to have a lot of conversations with the NEA, National Environment Agency, because we don't think. I'll give them the benefit of the doubt. I don't believe they understood fully their legislation. Now they fixed that problem. So the new restrictions, February 2026, it was previously restricted, but it was even too confusing for them. It's exempted in medical devices, fine. Aerospace and defense, fine. Replacement parts, fine. Plastics. But isn't this a flame retardant for plastics? Yes. All right. So where Dechlorian Plus is used. No, by the way, heat shrinks are thermoplastics, so it includes them too. Even though you might think they're rubber, they're technically thermoplastics. So it basically bans Dechlorian Plus except for all the places it's used, which is plastics. So don't bring it into in a barrel, but otherwise in a physical product, it's pretty irrelevant. So it's banned, but not really. Canada, Canada, you can buy stuff here that's banned in China. Canada is like least restricted jurisdiction in the world, other than the one who we're ahead of. We're just above the United States. Canada added to Chlorine Plus CEPA Schedule 1 that is now a toxic substance in Canada, and they're like, woohoo, that means we're doing stuff. No. So most of our human protection legislation is built on branding. It's on a toxic substance list, which means it's regulated now. No, it means we can talk about regulating it, which means Canada can regulate it, but hasn't. There is a proposal, it's been around for years, to restrict it, but that hasn't happened. So we'll see. It still technically is in a process to be restricted here. That would be, what's the term, surprising at this point in time. It makes sense to regulate the same way everybody else is regulating it, except the United States, because they're not a member of this whole thing. But this has been stuck in a proposal phase of different amounts. So last year, they definitely trumped the success. We got it on Schedule 1. Awesome, which means you can talk about it. Doesn't mean anything about it. So it's people live here. It was surprise people often how you can buy like the Chlorine Plus is more regulated now, not in physical products, only in chemicals in China than it is in Canada. Um, yeah, and they're the main users. UV328, another example pop. UV328 is a light stabilizer. 328 is 328 nanometers. It's a wavelength in the UV. And it's not just that one wavelength. It just centered on that one wavelength. And that's its real name. You can see why people call it UV328. It's not like Dechlorian Plus. It's not as much of a mouthful. It's just like a 2 tennis ball mouthful, not like my dog's 4 tennis ball mouthful, which makes fetch sometimes complicated. Haha, I got 2 balls. That means you're gonna have to give me one to throw the other. Or you can stuff them all in your mouth. That works too. It's a UV stabilizer for plastics. So it prevents sun fade. And its main use is the triacetyl acetate cellulose film, tack film, on the polarizers of an LCD screen. So like the screen in front of you right now, very, very likely has it. And it's this film, and of course, we take things apart in the lab. You're probably used to how many different layers. People look down at the bottom going, there are a lot of layers in an LCD screen. People here are like, yeah, there's a lot of layers. It's 2 of them. There's one on the top, one on the bottom. It's actually part of that layer. So we take that layer off and we try to take pieces of it. It's actually only one part of that layer. It's like the surface of one of the surfaces. So if you only take off one surface, the other, we get different results when we do testing. And so we have lots of processes around that and getting better at it. But it's the triacetylcellulose film that has UV328. And that's the only place we ever see UV328 at a real concentration. We do have some examples where it's contaminant levels, from other sources, often from its twin UV326, which is not as regulated. So, and the only place we really ever see it in real concentration is on that polarizer film in LCD screens. In the European Union, it's a REACH SVHC. It's been a REACH SVHC since December 2014. It's been declarable, so not restricted. You just have to declare it if it's above 0.1% by weight in a component. So an LCD screen would commonly have to declare it. It's now restricted under POP as of August of this year at 100 ppm. Note, it's exempted in TAC polarizers until 2030. Now, 2030 is not that far away, and that might get moved, but right now that's what it is. So all those LCD screens have to be redesigned for August 2030. Australia, it's 2031, which I'll get in a moment. 10 ppm in August 2027. And again, the not well thought out 1 ppm in 2029. Unlikely to stay. It would basically effectively ban recycled plastic because you'll get contamination. And some of the other UV stabilizers like UV326 have low concentrations in it because they're extremely similar. Australia, ICAMS, Australia, under the Industrial Chemicals Environmental Management Standard, restriction in Schedule 6. So you see the same thing. All these guys signed up for it, but there's only a handful of countries that really have a structure or will or persistence to actually do this. So they prohibited UV328 in July of 2026. Since there's no limit today, it's the SDS limit till they decide one. It's exempted from ban, and mostly these are until July 2031 in motor vehicles, TAC polarizers. Well, that's the main use, but 2031, not 2030 like Europe. Certain industrial coatings, photographic paper, and repair parts until 2044. So the polarizers have a little bit longer in Australia. Otherwise, the Australian restriction looks very similar to the European one. It is so similar that even if you're exempted in polarizers, like LCD screens, you're going to have a REACH SVHC-like communication requirement. So next year, when it's restricted, it's exempted in your LCD screens until 2031 from restriction, but you still have to communicate it in your supply chain like a REACH SVHC. By the way, I didn't mention in this one of the neat things, again, each country's legislative structure is different. ICHEMS does not apply to FDA regulated type products. So it doesn't apply to food contact or medical devices. And that's not part of the UN Stockholm Convention. That's just the instrument, the legal instrument the Australian government chose doesn't apply to medical devices. So they're excluded. So they don't have to do any of this. They're not exempted. Exempted means you still have to do this REACH SVHC thing. Excluded means they're not in this whole conversation. That's medical devices. So in Australia, the burden will often be put on the customs because you also have to tell national authorities if they ask you, which they'll often ask your customs broker to get the statement from you, so they don't have to worry about asking later. Again, it's the substance, the concentration, the volume, which they're not as likely to ask, but they could, and justification for use. And the deadline is July 1st, 2026. So if you bring in LCD screens, you're not medical, and you have the UV328, which most of them do, you're exempted till 2031 from restriction, but you have to do this SVHC-like declaration then. And we're putting together a structure of our own. So when you're doing work with us, when you get UV328, which when you have an LCD screens all the time, you're going to need a disclosure, REACH SVHC disclosure for Europe, and then you're going to need an Australia ICAMS disclosure too. Singapore, again, same control of hazardous substance in Schedule 2. They've restricted it. They actually restricted it earlier, but not in a way they understood or anyone else understood properly. So they re-restricted it for February 26, 2026 in a way they mostly understand. It's exempted in medical devices, adhesives and fillers, okay? Replacement parts, fine. Plastics. Hold on. Isn't the UV stabilizer for plastics? Like that's the only thing it does? Yes. Motor vehicles and the TAC polarizer. So in physical products, it's banned everywhere except for all the places it's used. Fine. So you can't bring it in as a chemical. I'm not sure how much. Singapore doesn't have a lot of space for factories that way, so I don't think they have that much industrial. So it's kind of a moot point. So they've implemented the restriction. It's just not banned in the stuff it's used in. Seems like a lot of work, but there's a whole bunch of other exemptions too. Canada, UV328. So they didn't agree. It was POP, which is actually not the first time they've done this. They've done this for persistence for things like the siloxanes, like D6. They don't agree. They said, no, we did the math. Our math is not the same as yours. We did your hand waving, and we don't agree with your hand waving. And by the way, Canada and the US often disagree with the rest of the world on SDS, like classification. Like Canada is one of the biggest reasons why endocrine disruptor wasn't an SDS designation until basically this year. So something, caused attention deficit. There was no that doesn't go into your safety. It's not a harm, mostly because Canada and the US were delaying that designation until this year. Now, endocrine disruption, your attention deficit thing is actually something that you can say a chemical has. We haven't got to the point where we can say a chemical causes Alzheimer's. That's oxidative stress. There's no category for that, and that's why they're not regulated. But we didn't agree with the POP designation, which they're allowed to do. Again, they've agreed to do it, but then when it went to their own legislative system, they went through risk assessment steps. If their risk assessment step says no, it doesn't go through their instrument. So there's no prohibition of UV328 expected in Canada. It can be reassessed, but that'd be very unlikely. So even though they're a signatory representative there, when it went through the Canadian government's legislative system, their risk assessment process did not agree with the POP designation. Therefore, it didn't get on Schedule 1, so they're not even talking about it. It didn't even make it to the talking about it stage. Now, again, a reminder, companies and products do not have to be compliant with the UN Stockholm Convention. The UN Stockholm Convention has no direct power over companies or products. You have to be compliant with the applicable national legislation. So in Canada, they said, nah, we don't think it's a POP. It doesn't apply to Canada. Of course, if you're selling the same product in Europe, you have to meet their requirements. So it's the main framework, and countries are signed up to do it, but they still have to implement these restricted substances through their own legislative structure, which may or may not make it through. So it might not occur in all countries, like Democratic Republic of Congo, for all substances, or it might be only in chemicals, which is common in what China does, or chemical in articles, which is more common in Europe. So tons of substances, the POP substances. The key ones for us in articles, DecaBDE, the nowadays very rare ROHS banned substance, Declorin Plus, the not quite as rare. Flame retardant, mostly in the transformers and power supplies. HBCDD, which is mostly phased out. The longer chain versions of PFOA, PFNA, PFDA, and all the way up to 21. Medium chain chlorinated paraffins is the brand new one, and we're putting everything in place to also be able to screen and communicate and test for MCCPs. We've always been able to test for MCCPs, but we've upgraded the screening technology. Our new screening technology is fantastic. PFOA itself, it kind of made the list originally by itself, all the different versions of PFOA, but now it's not just PFOA, it's all the longer versions too. PFHXS, which is pretty darn rare. Short chain chlorinated paraffins, which is the POP, applicable POP has been banned the longest. And that's, if we look, we did enforcement in Canada under the prohibition of certain toxic substances, SCCPs are banned. And that's probably the one, except for children's product, banned substance in all of Canada is SCCPs outside of children's products. And of course, UV328. That's the stabilizer in the screen you're looking at right now. So it's a webinar format. So if you have any questions, you can submit it to the control panel, and I'll try to get to as many as possible if I can make my screen work. This will eventually go on YouTube. One of the reasons we're doing it this way. Oh, question there about how about the other UV stabilizers? Are they on the same path? Not yet. Again, somebody has to nominate it. Could one of them, like UV326, which is very similar to UV328, get nominated? Yes, it could. It hasn't been. And so if it gets nominated, it goes through a multi-year process. So basically, as I said before, it has to be nominated with a whole bunch of details on saying why it's persistent, why it's bioaccumulant, why it gets around, and why it eventually becomes toxic. And then their committee, PPORC, evaluates it. And then if they all agree, there's a vote on it, and then it goes into Annex A. Once it goes to Annex A, then the countries will start having to implement it, which Europe right now is generally the first one to do so. However, Australia has been moving with more expediency than before. UK also implements it, but they don't understand what they're doing. So they've had situations they've banned a substance before everybody else has, because everybody else is banning it, but they didn't realize nobody else has. So, and then they unbanned it, and so they have complicated problems. So you'll see some countries trying that are new at it, like the United Kingdom. With their newer government, they're more likely to regulate things they've committed to. But UV3, the other UVs are only in the REACH SVHC, so you have to communicate them in Europe, but they're not restricted. And we see UV326 relatively commonly in plastics. Is DPDP a POP? It's treated like a POP. They'll handle it like a POP. It's actually not in the list. There's some argument whether it's in the DecaBDE family. It isn't. It's not quite as clear. I was looking at them myself. It's a lot of Canada and Australia and Europe are all implementing DBDPE restrictions, but it related to the Stockholm Convention, but it didn't actually come through here. So that is a bit of an interesting question because it's being regulated through all the same mechanisms, the European level, the Australian level, the Canadian level, but it's not on the list we see here. It's always an interesting one. Could be in one of the other annexes. I'm going to double check. Well, thanks again, and hope everybody enjoyed lunch. And of course, if you weren't here at lunch, well, you're always welcome to visit. If you do come here, you're welcome to visit, and we might even get you lunch. Um, but and hope if it like all of our lunch and learns, you get everybody gets to see this. The idea is we're educating our people internally. Why don't we take this knowledge and let the rest of the world see it too? So if you're seeing this on YouTube right now, great hosting you, a pleasure hosting you. Everybody here at Claigan, again, a pleasure hosting everyone here. And you probably recognize some of these chemicals and all of the detailed processes we have to answer them. So thanks again, and I look forward to hosting everyone again soon.